Hello AS, or should I say soon to be A2 students. This is the summer task that I need you to complete, unsurprisingly, over the summer. So this will prepare you for the very first tiny little bit of research methods that we're going to do. So you know everything there is you need to know, not everything there is to know, but everything you need to know about research methods, apart from statistical testing. And a lot of this information is going to be a recap. There's going to be a little bit of new information which will prepare you. In previous years, we've taken about 4 weeks to cover this last little chunk of research methods. However, doing it this way, I think we could cover the research methods in 1, maybe 2 weeks, which will give us a bit more time at the end of the year for the revision. And I know you'll be sad to hear that, because I'm sure you're all a huge fan of research methods. That you won't have as much time on it, but I'm sure we'll all manage and power through. And of course, we'll still be looking at it almost every week in all the other lessons as well. So, statistical testing, as you all know, when you want to conduct a piece of research, you write hypotheses, and you learned about you write a hypothesis, and you learned about hypotheses in the first 2-hour session that you did with me. You always write an alternative, and you always write a null hypothesis, and hopefully you all can remember that that's because to ensure that it's objective. So you're not just saying, I'm definitely going to, if you only wrote an alternative hypothesis, you'd be saying, I'm definitely going to find this, boys will be faster than girls in a driving test, or whatever. So you have an alternative which predicts what you might find, but then you also have a null hypothesis which says there will be no difference between. And this isn't necessarily relevant now, later in the video, I don't think. However, it is a really key part of statistical testing, so I want you to make a note of it and remember that this is really important for when we talk about type 1 and type 2 errors, which we don't do on the video, but we will do the first week back. And that is that your default is always the null hypothesis. Okay, so you write 2 hypotheses to ensure that it's subjective. However, we talk about accepting or rejecting the hypothesis depending on the results, and we always use the null hypothesis, and that is because of the process of falsification. So the idea that we must always disprove a statement. So we have the statement of there'll be no difference between, and then we disprove that by finding there is a difference between. Okay, so it's always the null. The null is always the default one that we use. We write both, but the null is always the one that is the main focus. You have both your hypotheses, you then collect your data, and then the next thing you do with your data is, rather than just eyeballing it like you do in the exam, you conduct a statistical test. So you look at the data and you make a judgment, or the statistical test that you use, the equations that you use, tell you the likelihood that if this finding is true, boys are faster than girls, the likelihood that you would get this result. Okay, the key thing though, don't worry too much about that if you're not sure. The key thing to remember is we then do some statistical analysis. We do some mathsy stuff on the data, and then we accept or reject our null hypothesis. So if our results are significant, if the statistical test tells us yes, the results are significant, you have found a statistically significant result. If this was true, boys are faster than girls, we would most likely, your data has exceeded the threshold to make that statement true. Then you would reject your null hypothesis that there's no difference between boys and girls. Or if we didn't find that, we'd accept our null hypothesis that there is no difference between boys and girls. Okay? All of this you have done before. The only bit that's new is conducting the statistical test. You do not, and it's not actually completely new to you either, because you have covered the sign test with Andy. So that was the pluses and the minuses, and you looking at the least frequent sign. That is statistical testing. Okay, so you do already know one statistical test, the sign test. That is the only one that you have to conduct in the exam, or calculate in the exam. You will not be expected to conduct or calculate any statistical tests, but you do need to know the theory behind them. So one of the most likely questions that you'll be asked, which students always hate and find really terrifying, and this is in your booklets as well, so don't worry if it's not too clear on the screen, is how do you choose which statistical test you are going to use? And you've got here, they're all listed here, so these are all the ones that could be the possible answer. So chi-squared, Mann-Whitney, unrelated t-test, sign test, which you're familiar with, Wilcoxon, related t-test, and then we've got the chi-squared again, the Spearman's Row and Pearson's R. Okay, and you will get very, very comfortable and very, very familiar with those. This is one way of you working out how to use the statistical tests, and this will make more sense when you've watched more of the video. Okay, there is also a flowchart in your books, which is another way that can help you work out, if you answer all the questions, it helps you work out which statistical test you should use. Okay, to pick a statistical test, you need the 3 Ds, and that's how we remember it. Okay, difference, design, and data. And you could be asked the question either the experimenters use Spearman's Row, explain why they use Spearman's Row, and you would talk about the 3 Ds, or it would say identify the statistical test that you would use and explain why you would use it. And that would usually be 4 marks, 1 for the statistical test and 3 for the 3 Ds. Although it could be smaller, they might not want all of the 3 Ds. Okay. So the first question you could ask yourself, and there are some questions in your book to go with this, a very short activity to go with this, so have a look in your booklet as well, is it a difference or a correlation it's looking at? And in your book it asks you what word tells you it's a correlation. So in the exam, if you're in the exam, I want you to know what word did I repeatedly, consistently drill into you, what word should you be looking for if it is a correlation. Okay. If you don't see that word, we're looking for a difference. Boys will be quicker than girls at driving ability, girls will be better at maths than boys. That's looking at a difference between 2 conditions. People who drink caffeine will remember more words than people who don't drink caffeine. We're looking at a difference, whereas a correlation is slightly different. So have a think about that. So that would be the first one. So if you just pause here, fill in a very, very small number of questions about correlations in your book. The next D is design, and again there's a work section in your booklet. This one is completely revision again as well. The only D that is new to you is data. So experimental design, as you all know, is not lab, field, natural and quasi, as we talked about a lot in class, so hopefully that's all drilled into you. Experimental design, you've got repeated measures, independent groups and match pairs. So one of the things you'd need to do is read the stimulus and decide which one of those it is. If you were asked this question, which statistical test would you use? So again, if you want to pause the video here and fill in that little section for revision for your experimental design. And finally, the third D is data, and that's what we're going to look at now. And as it says there, if you watch the next section of the video and make notes as you go. Okay, there are 3 types of data, or as it says there, it's not levels of significance. Apologies, 1 second. There we go, that's fixed it. So apologies, levels of significance are something within statistical testing, but we don't touch on those until September. I'm saving the best until then for you. So we remember that there are 3 types of data, and we remember them as D for data so that it fits nicely with the 3 Ds, difference, design and data. However, you could also be asked about levels of measurement. Don't be put off in the exam, they're both identical things. So if you're asked about the data or the level of measurement, you could talk about either of these 3 things we're going to talk about now. Just for the statistical testing, it helps to remember 3 Ds, but it also can be known as level of measurement as well. So the first one, nominal, is the least scientific, the least precise, the least accurate, and I remember M for nominal, N for naming, and it's naming categories, and there's some examples here below. So what's your gender, male or female? And of course there could be more categories than that as well, but these are just the ones that I found on the internet. So you can be placed in either the male or female category, or hopefully there's a few more in more modern forms as well. Or what's your hair colour? Brown, black, blonde, grey, other. All they're allowing you to do is to be placed into one category, and that's it. There's nothing else we can do with them. Or do you live north of the equator, south of the equator? Are you a first year? Are you a second year? These are all, do you own any pets? Do you own cats or dogs? There are certain categories that you can put in place. All you can do, or all the information you can provide if you collect nominal data, is frequency. So all you can tell me is this many people are male and this many people are female, or this many people have dogs and this many people have cats. That's all you're able to do. Okay. What you can't do, exactly as it says on the slide, is place them in order. So whilst some of you may suggest this is the case, I'm sure Andy would be one of those people. You can't say, all you can say is that 5 people own cats and 10 people own dogs. You can't tell me if owning dogs is better than owning cats, or higher or lower. All you can tell me is the frequency of them, that's it. And the same with hair colours. You can't tell me that people with blonde hair are better than people with brown hair. All you can tell me is 5 people have blonde hair and 30 people have brown hair. So the only kind of measure of central tendency that you can use is mode, which is the most frequent. Okay, so this one is the least scientific. It's categories which can't be placed in an order, which only provide you with information about frequency. So the only measure of central tendency you could use is a mode. You can't add them all together and divide them by the number that there are. That wouldn't work. And you can't do median either. You can't place them all in a line and tell me which one falls in the middle. The next one along is ordinal, and the word ordinal suggests, is that you can place them in an order. Or if you want to remember R for ordinal, because the R's in there, and then R for ranked, you can rank them. Okay, so you can tell me which is better and which is worse. And a really common version is what we can see down here, which is the Likert scale. So how happy do you feel today on a scale of 1 to 5? Or it could be how much do you agree with a statement, and this one would be Likert as well. Strongly agree, somewhat agree, neutral, somewhat disagree, strongly disagree. And I'm sure you've all done surveys, probably in college, where you can do that. So I can tell you that if somebody said they strongly disagree and somebody else is neutral, that I can place them in an order. This person more strongly disagrees, so is higher or lower on the spectrum than the other person. The other thing that we can do is a way that ordinal would work is ranking, so first, second, third, fourth, fifth. So I can tell you who finished first in a race, who finished second, who finished third, and who finished fourth. However, with ordinal, the distance between the categories is either unknown, so I don't know if first and second came really close together, so there was a 1 second time between them, and then second and third there was 5 minutes between them. All I know is the first, second, and third. Or if I do know the spacing, so very unsatisfied, somewhat unsatisfied, neutral, that is subjective. And that's something you've talked about with Andy as well, I believe, when you looked at types of questions. What one person, the difference between very unsatisfied and somewhat unsatisfied for one person might be quite small, whereas another person might interpret very unsatisfied as being wildly different from being somewhat unsatisfied. So the distance between the categories is subjective, and also what one person thinks is unsatisfied, another person might think is very different as well. So the difference between the categories is unknown or is subjective, and really the most common measure of central tendency with this one that you could use, or the most complex, would be median. Okay, so placing in the middle. So that's ordinal. You can place them in an order, or you can rank them. We don't necessarily know the spacing between the categories, and you would use the median measure of central tendency. And then interval, which is the most precise and scientific, which we look at. And the way I recommend people look at for this one is it's generally a standardised measure. So anything that you would recognise as a key measurement. So time in seconds, well, seconds is a standardised measurement, so we'd recognise those. Height, centimetres, metres, inches, feet, depending on how old-fashioned you are. Temperature, as it says on the board there, you've got another one. They use Celsius or Fahrenheit. Everything that has a kind of a recognised measurement would be interval level data. However, and that's an easy way to spot them and think about it. However, a key thing, the real true difference between ordinal and interval is that the space between each unit is equal, or if you want to use the fancy word, equidistant, which don't worry too much if you can't remember that, but that's the idea. So we talked about before in ordinal, the difference between first and second, that we don't, and the second and third could be hugely different. So first and second could be racing each other for a photo finish. They both cross the line, one's a toe in front of the other, whereas third might be miles and miles behind and take ages to catch up. So, whereas with interval, and we don't know what the distance between them is, with interval, if you're using an interval level of measurement, you know that the space between each unit is equal. So the difference between 1 centimetre and 2 centimetres, the space in between them is a centimetre. The space in between 10 and 11 centimetres is also a centimetre. So all of the distances, the units, and that's really key, the intervals between each unit are equal and set. And with this one, because it's the most precise, you can use the mean, and you can use the standard, and you can work out standard deviation as well. Okay, so that's the most important one. So this signals the next part of the test. So summer task, apologies. It's not a test, don't worry, not until the first week of September. So if you could just pause wherever you are, using the notes you've got, you can have another listen to my information. The people on the board now, Tutor to You, also have a really good video, so if my video is not making sense about levels of measurement, you could look at that. There's a wealth of information on the internet, so if you Google levels of measurement or even the words nominal, ordinal or interval, you'll find lots and lots of different things. If you're really not sure, the best way to do it is to read about loads of different examples. So there are big lists on the internet of examples of nominal, ordinal and interval level data. If you read all of those, it will tell you all about those. Okay, so if you want to pause the video here and complete your activities on levels of measurement. Okay, now you know about the different levels of measurement, you know about all 3 Ds, difference, design and data, and there are 2 ways that you can then decide which statistical test to use. The clear, simple way, when you're already learning lots of complicated information, sometimes you need to start simple, is this decision tree is really nice and clear. So you ask yourself several questions, it flows down, and then it tells you, is it Spearman's Row, is it Mann-Whitney, is it Wilcoxon, and so on. Okay. A little bit of a cheats way that helps you a tiny bit, perhaps not as much as you would like, is where it talks about unrelated and related. So you've got related Wilcoxon, and you've got unrelated T and related T, and the sign test as well is also called it. Then that related and unrelated just refer to the experimental designs. So unrelated, the 2 conditions, the 2 groups are unrelated. So you've got independent groups. Condition 1 and condition 2 have different people in, they're unrelated independent groups. Or if the 2 groups are related, the same people are in condition 1 as condition 2, or it's match pairs. So similar people are in condition 1 to condition 2, they've been matched to design that, then it's called related. It's a related test because they're similar. Now don't just stick related and unrelated on as you think, but if you can remember related and unrelated T and you can't decide between the 2, you think, well, it's independent group, so it's got to be unrelated. Okay. The other way, let me see if I've put it on the video, I haven't, the image that I showed you earlier, in fact let's go back to it so you can see it, is another way that is slightly less clear. However, the reason I show you this one is once you've got your head around it, this one is perfect for memorising because it's much easier too. Okay, so if you look along the top, and you've got it here too, you've got carrots should come mashed with Swedes under roast potatoes. The C in the chi-squared, carrots, S should come mashed with Swede under roast potato, and then you've got it here as well. So that would help you. So if you knew if it was a test of difference, which is along the top here, so you know it's a difference, you know it's independent groups and it's nominal, you know that it's chi-squared. Okay, so this one slightly more, can be a little bit more tricky at first, so if you can't get your head around it, start with the flow diagram, the decision tree, and then afterwards when you become more confident, use the little table because that will help you memorise it. Okay, so as you can see from this table, the first question, you could do everything on this table to tell me which one it is, chi-squared, repeat as the sign test. The only question you can't answer at the moment, which you'll be able to very soon, is can you use a parametric test? There are 2 types of statistical test, and you don't need to know much about the difference, but you do need to be able to decide would you use a parametric or a non-parametric test. Parametric tests are better, more pure statistically. They provide you with better information. However, it's all a scale of balancing. They are very good statistically. However, they are affected quite badly, quite significantly by poor data. So if you can remember, I said interval level data is the best type of data. Nominal and ordinal aren't so good. Parametric tests you can use for interval level data because the data is really, you're putting in really high quality data, whereas non-parametric tests, which is the name for the other type where you'd say no, they can't deal so well, or they're not as precise and scientific and pure. However, they deal really well with when you're putting not such good data in, so nominal data or ordinal data, okay? Or if there's a couple of other problems. So if we could take out the parametric test part, you would be able to use this flow diagram really easily to decide which statistical test you would use. So all we need to do now is help you answer, can you use a parametric test, yes or no? And this is what you would do. To be able to answer, or to be able to decide, is it parametric or non-parametric? If you answer yes to all of these questions, these three questions, then you can use parametric tests. If you answer no, then you cannot use a parametric test. So usually in the exam, most commonly, this one's the easiest one to answer. Is the data or level of measurement, because they're both exactly the same, nominal, ordinal or interval, is it interval level data? Yes, parametric, no, non-parametric. Okay. Are the standard deviations between the conditions similar? Again, yes, you can use a parametric test. No, you can't, because if the standard deviations are similar, the data is similar, which means that it's good quality data. If there's a very big difference between standard deviations, then it's poor quality data, and you have to use a parametric test. And is the data normally distributed? Yes, parametric. No, non-parametric. Okay. So what I would like you to do now is, if you have a look in your books, I would like you to complete the worksheet and exam questions on standard deviation. Have a read, a very careful read. I think this worksheet, which isn't one I've made, I think it's really, really effective. Really, really shows quite clearly what standard deviation is. I'm sure some of you saw in the mock exam there were standard deviation questions. Also, they are extremely common in the second year exams. So what do the mean and standard deviation tell us about the data? And you can get questions up to 6 marks. So you want to be really, really confident on standard deviation. Have a look through the worksheet, complete the exam questions, and then come back, because we'll move on to the next thing. Okay. And then distribution. So again, you've looked at both standard deviation and distribution with Andy, but I'm going to refresh your memory here. We'll touch on it briefly here, and then we will look at it more when you come back in September. But please have a basic grasp of what it is. So a normal distribution, which is what you'd use for a parametric test, because the data is good, and therefore the parametric test can really focus on doing what it should be doing, which is working out the statistical data, if it's a normal distribution, then it's the one in the middle, which means there's no skew whatsoever. So it looks like this. And I don't know if any of you can remember what a distribution was called. A normal distribution, another name for it. It's called a bell curve because it's the shape of a bell, and that means that the data is well distributed. IQ, for example, you would find IQ looks like this. Positively skewed data means that a lot of the data is at the left-hand side of the graph, so the lower level. So if this was a test and everybody had positively skewed data, that would tell me that the test was very, very difficult, because you were all down here with 1, 2, 3, 4, and very few of you had 10, so you'd have quite a low mean. Whereas here in the middle, I would know that this is a perfect test, because a small number of people didn't do very well, a small number of people did really well, and most of you, the average number of people in the middle, got the middle scores, which is what you'd expect. You'd expect a couple of people to get A's, most people to get C's, and a couple of people to get U's. Okay. Whereas here, lots and lots of people. Are getting, apologies, I suppose it would all depend, wouldn't it, on how you place it down, but say this was 1 to 10, so lots and lots of people, let's do it that way, apologies, so lots of people getting, say, 1 out of 10 here, and 10 out of 10, and most people getting around 5 out of 10, whereas here you'd have one or two people getting you'd have most people getting, say, one or two out of 10, and very, very few people getting 10, and a smaller number getting 5. Okay, so most people got 1 and 2 on the test, a small number of people got 5 on the test, and then very few people did well on the test. Okay, whereas if we're going with a negative skew, this would tell me that the test was really, really easy. So very, very few people got 1 out of 10, a small number of people got 5 out of 10, and most people, lots of people, got 10 out of 10. Negatively skewed data and positively skewed data isn't helpful or to tell me anything about the population as a whole. All it's telling me is that everybody can do something really well, or nobody can do anything at all. It's not telling me any kind of subtleties in that. So those two tests weren't very good, they weren't helpful, whereas the normal distribution tells me what the average is and tells me a bit more about the details. Okay. Oh, I've taken this out. So there is a way that you can help remember positive and negative skew with your left and right feet, but I will come on to that later. Again, probably in September as well. So just for now, make some notes, try and understand, have a little bit of a read of positive and negative skew. Again, if I've made no sense, have a quick look on YouTube. There's other videos. Have a quick look in your textbooks if you've still got any textbooks, or just Google it and just get a feel for that. Because to be able to use a parametric test, we would have a normal distribution. However, we might find we have a positively or negatively skewed distribution, and therefore we cannot use a parametric test, because the answer is no, the data is not normally distributed. Okay, so just to go back briefly, the 3 questions you would ask yourself: is the data or level of measurement interval? Yes, parametric. Are the standard deviations between the conditions similar? Yes, parametric. Is the data normally distributed? Yes, parametric. Or no to any of those, and then it is non-parametric. So you can remember no, non, very similar words. Okay. Once you've answered that, you can then use the decision-making tree. So can you use a parametric test? Well, the data is not interval, so the answer is no. So you go here. Is the data nominal? Yes, the data is nominal. So the next question was it independent groups design? Yes, so therefore it was chi-squared. Would be an example of how you might use it. So you're just using the decision tree in that way. So the key thing is, and you might want to include those 3 questions on this flowchart near the can you use a parametric test section, because that's the first thing you'd need to ask yourself. Usually, we don't usually get to the skew and the standard deviation. Normally it's no, you can't use interval data. No, it's not interval, so therefore you can't use parametric. But not always. So you do need to have them in the back of your minds. Okay. If you're really, really lost, just try and understand all the individual components. So try and understand what levels of measurement are, try and understand what standard deviation is, and try and understand what the distribution means, and in class we'll put them together. But the more you can try and put them together now, the better, or the easier your life will be in September. Okay, statistical or inferential test questions. Now, I've been calling them statistical tests. Chi-squared, Wilcoxon, sign test. However, another name for them, and this is only so you don't panic if you see it in the exam, is also inferential testing. So just make sure that if you see statistical or inferential testing come up, that immediately in your head words like Wilcoxon, chi-squared all pop up in your head. Okay? Key things. So for these questions, it's generally 3 or 4 marks. So it's either they used the Wilcoxon test, why did they use it? Or it's 4 marks, identify the test you would use and explain why you'd use it. But you've got all of those skills already. So you would identify the test, and then it's the 3 Ds: difference, design, and data. So as with every single question, and these are the questions that I worry about, you want to think about in this study, and you must make sure almost all those questions have that, so you must make sure you contextualize. So there are some questions that you're going to have a practice of in your booklets that say in this study. So if you said I'd use the unrelated t-test because it's interval level data, it's looking for a difference, and I said unrelated, didn't I? So independent groups, you wouldn't get any marks, or you might get one for identifying the test. You must contextualise. So you would say they're looking for a difference because they're comparing boys and girls. It's independent groups because you can only be in the male condition or the female condition. Again, being very stereotypical, apologies. The data is interval level data because it's timed using seconds. So you have to link it back to the study each time, okay? And as it said under there, so cross, so you wouldn't get any marks for just saying repeated measures, but you would get marks for saying repeated measures all participants take part in the music and no music condition. Hopefully you're all completely fed up with the word contextualising, you're familiar with it now, you're used to the concept. If that's the case, brilliant. I'm glad, that's exactly what I want. I want you to be really bored, because hopefully that means, fingers crossed, that you will then do it in the exam. Okay, so just remember that when you go through the exam questions. So that is everything you need to know, information that you need to know. Let's just quickly go through the booklet so you can be confident that you're completing the bits that you need to complete. So here's just a little bit of information, so if you were horribly lost you can have another read of that, and hopefully it will help you a little bit just to introduce the really simple concepts of statistical testing. Remember, if you're really confused, just try and understand all of the different things individually. Then you've got the difference or correlation, just answer a couple of questions about correlation. You've got questions on design here, so a bit of practice of questions which we'll go through the first week back. A bit of detail about interval, ordinal and nominal data, and here's an activity where you say, oh, it's interval level data because, so it's really key which data and most importantly why. That could be another question on the exam. Identify the level of measurement and explain why it's this level of measurement, or if it's in a contextualised, you can't just say, oh, it's interval, you've got to explain why it's interval as well, so that's really important practice. Then you've got this decision making tree here, or you can use this table straight away, whichever you prefer, whichever makes most sense. If this really confuses you, I'd probably start with this one. The only danger with this one is that it doesn't ask about the parametric test, so you just need to remember about parametric tests. This is standard deviation. So they're the three questions you need to ask yourself about parametric and non-parametric test. This is the standard deviation worksheet, as is this. So read this information carefully, look closely at these data sets. Okay, they're very helpful. So just think carefully about that, and then do the matching, and then have a go at some exam questions. The key thing with these exam questions, what does the standard deviation tell us about the performance of the two groups, is it's 2 marks, so you need to do 2 things. You need to tell me what it tells us, and then you need to be able to explain how we know that. And I'm sure we've done this in class. So for example, the key thing to remember with this is high standard deviation means the data is very spread out, and a low standard deviation means that the data is very tightly packed around the mean together. And you would talk about that. So you would say, this suggests that, and I'm not looking at this question now, so don't think I'm giving you any answers, don't get confused. So I might say something like, because the standard deviation is high in the no music condition, that tells us that the data is very spread out. And that's what you would need to do. Okay, and so just make sure that you do that. The mean and standard deviation. The mean tells us the mean tells us this. We know this because. Okay, and here it is. So you've got information about distribution, and this one here, which is your right and your left foot. So if you plant your feet, take your shoes off, and plant your feet firmly on the ground, then you have. And yes, think about, apologies, I should have been careful when I said about the grades. Think that this is 0 and that's 10, so we have it this way, 10, and the scores being higher. If you plant your feet on the ground, then the left foot is like a negative skew, and I always remember the E for negative and the E for left are in the same place, and then the right foot is a positive skew. Okay, but again, we'll talk about that more in class. If you need to, you've got a couple of distribution questions for you to have a practice of and to sketch some graphs quite simply, and then you have some questions here, which is where the decision tree or the table itself comes in really handy, where you have to decide, and I want you to include all 4 levels of information. So which test would you use, and the 3 Ds: difference, design and data. And again, they're up here if you need reminding of them when you get to this point. And then there are exam questions here. Explain why the chi-squared test is appropriate to use in this case. Justify your choice. Justify your choice. So you've got to tell me which statistical test and why. Okay. The most important thing, if you get lost or stuck at any point, just email me and let me know, and we can talk about it. Okay, I'm in and out over the summer, so it might take me a little while to reply. As with my advice, don't leave it till Sunday night, because if your lesson was on the Monday, for example, or Wednesday night if your lesson was on the Thursday, because I won't be able to reply to you. However, if you start it now, even if it doesn't all make sense, you've got lots of time to work on it and check with me if you've got any questions at all. So please, plus you want to come back to college feeling nice and refreshed, so don't leave all your homework till the night before, because you will not feel nice and refreshed ready for college. You've got a whole summer, just chip away a little bit each time. Okay. So just contact me if you have any questions at all. Otherwise, have a go at it, and we shall look at it the first week when you get back.